Hi, everybody. Tricia Cease here, president of the Virtual Foundry. And with me, as always, is Brad Woods, our founder, chief scientist, chief metallurgist, chief engineer. He wears a lot of hats around here, and we're so glad that he does. The date is Friday, February 19th. It is 10:36 a.m. in southern Wisconsin. The temperature outside is 16 degrees Fahrenheit. That's -9 for all you Celsius users. So still pretty chilly here in southern Wisconsin, but we're going to see a really nice warm up coming over the weekend and into next week. We're all very ready for that. Today, we're going to be talking about powder metallurgy. So that's the field in which we play, and in the finer scope, metal additive manufacturing, but it's all based on powder metallurgy. So Brad is going to tell us about the history of powder metallurgy and the technologies that have been using that for a very long time.
Right. It's been Powder metallurgy is really surprisingly common in some really crucial technologies. The easiest one to talk about is the auto industry. It's generally accepted that each car on the road today has about 20 pounds worth of parts that were made using a powder metallurgy technique. And the most common one, and these go back to the early 1900s, are self-lubricating bearings and bushings. So they'll take powdered bronze, press it into a compact, and sinter it. And the advantage of that strategy is that there's porosity. That porosity lets the oil flow directly through what would otherwise be a solid object. So they call them self-lubricating bearings, and they're all over the place. There's lots of them in your cars, and this is becoming all of additive manufacturing today is built, at least the parts that are based on powder are built on these same technologies. There's very little difference between those the older manufacturing techniques and the new ones. The crucial change has been in the additive world, we've come up with better ways of forming the powders into more interesting shapes. And ultimately, it's really about that simple.
So those older technologies and the ways that you're getting to those parts that you were talking about that are in all of our cars, press and sinter, metal injection molding, powder injection molding. Just talk through those a little bit.
Right. So the one that probably relates the most closely to the techniques that we're using for additive manufacturing is metal injection molding. And this has been very common for, probably the last 30 years. It's becoming a common industrial manufacturing technique. And it's done with very high precision parts that you might not even think of right off the bat, like parts of, if you have a Leatherman in your pocket, parts of that are likely made using powder metallurgy. And this strategy is very analogous to the Virtual Foundry's concept of bound metal 3D printing. So what they did in metal injection molding was they would pretty much add wax. And typically it was as simple as adding paraffin or something like that, something that was just strong enough to hold the metal parts into, or the metal powders into a form. They would then use slightly modified plastic injection molding equipment to inject this into an injection molding die. From there, it would, come out of the die. It would go through a debinding phase and a sintering phase, exactly like you do with our materials now. The difference, obviously, we use FDM to add up layer by layer and build objects that way, and we don't need the die part of that strategy.
Right. So those early technologies that we talked about that used powder metallurgy are still very much in use today. And in fact, they're expanding.
Yeah.
So those technologies certainly haven't gone away. They're still around and they're growing. So then we add additive manufacturing to the mix. And as you and I have talked about before, additive manufacturing isn't a replacement for any of the current technologies. It can be in some applications, but it really just is a brand new way of making things and opening it up so many more possibilities. So there are lots of additive manufacturing, metal additive manufacturing technologies that are using powdered metal. Ours is a great example. And as you were just saying, we're very much modeled after the metal injection molding formula. So we've got metal powder with some kind of binder holding that together. We happen to put that combination into the shape of a filament that can be 3D printed. Metal injection molding feedstock is different from that. But we're all going through the same process then. There's a extrusion process, then a debind process, and a sintering process. One of the things that we really like about our material is it's thermal debinds. There's no chemical involved in that process, but otherwise we're following pretty much the same formula. Talk about some of the other additive manufacturing techniques that are using powdered metal.
We'll do that. Here, I'm going to attempt to pull up share a screen in Zoom here. So this is a quick graphic of the generally accepted ISO technologies for additive manufacturing. VAT is plastic only, those are photopolymers, but the rest of them, material jetting, binder jetting, lamination, material extrusion, powder bed fusion, and directed energy deposition are all methods of additively creating a metal object. And most of them in this list work on the concept of a powder bed. So you lay down a thin sheet of powdered material, and then you hit it with a laser to melt it into place. So you're either hitting it with a laser, or maybe you're hitting it with electron beams or something like that. There's a lot of different strategies. The strategy that the Virtual Foundry uses is more like a material extrusion technique. Let's move to the next graphic, and let's talk a little bit more specifically about the Virtual Foundry and what we're doing. So this is just kind of an interesting graphic that's floating around out on the internet. And it's sort of a compilation of lists of different papers and research papers that people have done all the way back to 2000 on powdered metals and the relationship between particle size, particle shape, particle density, the texture of the particles. When we get down to the specifics of making a new material at the Virtual Foundry, every one of these properties plays a crucial role in how we manufacture a new filament. And very minor changes have surprisingly dramatic impact on the final product. So these are things that we've built into our process. We're up to, I think, 14 stock materials right now. And we've done probably a half dozen, 4 to 6 others that are just custom materials for people.
So that's a great point. We're using the same powders and the same sources as the other additive technologies today, the DMLS, the binder jetting, and those are the two major ones. So we're sourcing these from the same place. They are substantially similar to the powders that the other technologies are using. We're looking for a specific size and shape combination that allows us to get the most metal into the material that we can get to. And that has been a years-long study that Brad has worked very hard at figuring out that balance between high material load and usability, toughness of the material, flexibility of the material, and finding that sweet spot between those two. The percentage of material load creeps up higher and higher as all the technologies improve, as well as our own here in-house.
From the beginning, the quality of the material or the quality of the part that can be produced using our material is dependent upon how much metal we can get into the polymer. And the limiting factor there becomes it being in the shape of a filament. So, people talk about filaments being brittle and things like that. And it's always going to be true that our material is more fragile than PLA plastic. That's just a given. But what's happened is we've been able to improve the polymer. We've been able to improve the metal particles that we're putting into the polymers. And we've been able to get these numbers higher and higher as time has gone by.
Brad, what do you see as the future for powdered metallurgy?
The future is kind of, I think it's kind of summed up by the past. Things are exploding in powder metallurgy. Everybody from our perspective is thinking of it as additive manufacturing. But it isn't just additive manufacturing in its relationship to powder metallurgy that's growing. It's powder metallurgy as a science is also expanding very quickly. So we're going to see rapid change over the next few years, not just in additive manufacturing, but also in the powder metallurgy part of final part densification, final part properties. We have new materials coming online. Graphene is the latest recurring topic, comes up a couple times every week. So we're able to add new properties to materials that have existed for a long period of time.
And in the future of the Virtual Foundry itself, it also will involve putting these metal powders into different formats for different technologies. For example, a pelletized version of our filament, which is available today, can be used in a metal injection molding way. Brad produced a video about that, about his experiments in his own lab, and that is posted on YouTube. I'll put a link to that in the comments so you can look at that experiment that he ran around here. But also getting our filament materials into different shapes to be used in those different technologies. So that's some of what the future holds for the Virtual Foundry here within the broader scope of powder metallurgy, being not necessarily limited to additive manufacturing, but branching out into other ways of making things.
Yep.
I have one more very important question for you before we wrap up, Brad.
All right.
What do you call a pig that does karate?
Something with chops.
Oh, you're very close. It's a pork chop.
Nice.
Well, thanks everyone for joining us on the podcast today. We'll see you next time.